I hope you managed to read my presenter notes when we were prepping this, because I don't have them here. My name is Valeria Bogatyreva. I'm working in product marketing at the company called Percona. Before you run away from this talk thinking that this will be another product pitch and I will encourage you to buy something at the end, don't worry. This is rather a conversation about how to stay secure and compliant without giving up the open source freedom of PostgreSQL. So whether you are a data analyst, DevOps, engineer, or you work in the leadership of the company, you may have noticed that in the past years, the compliance regulations have become tougher. The attacks have definitely become more intricate, as we have already heard on the talk earlier today. But unfortunately, the company budgets to tackle these attacks and to comply with new regulations are not growing. And so this is what we are talking here today about, how to comply without adding more complexity to the whole process. In general, I think going through the compliance with any regulation may be a bit like a dental appointment. It is for sure necessary. It may be painful, but if you avoid it altogether, there will be big consequences at the end. The clicker doesn't work. All right, so on this image here, you see a DBA in the middle running a compliance maze. In 2025, there are endless number of compliance regulations and local policies to comply with. There is PCI DSS, HIPAA, ISO. Has anyone heard about LGPD? Yeah, what is it? It may be. I'm sure you may be right. To be completely honest with you, it was a hallucination of my AI, but I'm sure it took it from somewhere, so your guess is valid. So this is not, of course, the full list of regulations companies need to comply with, and each of them introduced their new changes in 2025. The changes are numerous, but the essence of them is actually that they want companies to encrypt. Most importantly, they want companies to prove that they can actually encrypt the information. On the next slide, I collected a few of the changes that came to action in 2025. So for HIPAA, this for the pharmaceutical companies, there are more stringent encryption for electronic health records, so for all of the patient data that they are storing on their SQL databases. PCI DSS, this is for the companies who store the cardholder data information. There is new requirement for stronger database encryption, access controls, and real-time monitoring. SOX-Oxley Act, this is the one that protects the financial reporting for the investors, asked for tighter audit trails for financial data. GDPR, which is relevant for Bulgaria, requires more consent management and also imposes higher penalties for the companies that don't log and store the user consent in the databases. Finally, CIS puts more emphasis on the database configuration controls. Now, as I mentioned, those are the changes that came into effect in 2025. And 2025 is almost over. In a few months, we are going to face a list of the new set of changes that companies will need to comply with. And this means that being compliant is no longer a checkbox that you need to tick every once in a while. It's more of an ongoing and continuous effort and process. So what every compliance framework is actually asks you to do can be narrowed down to these 5 things. Firstly, they are asking for encryption at trust, that your data on the disk must be unreadable and must be unreadable to unauthorized users. The second one goes hand in hand. It's encryption in transit, protecting data over the network with TLS processes. Then there is a key rotation, and of course, if you have the key rotation, there should be a documented key usage. You need to be able to prove what's encrypted and how it is encrypted. And finally, there is access controls. Only privileged users can manage the encryption keys. Now, I would say that these 5 alone cover most of the compliance checklist. And quick story, I interviewed once a customer who shared that he managed to write a short novel into the attempt to explain to his auditor how the encryption works in his organization. And this is not any of us want to do on our daily basis, writing novels about the encryption. And this is why the simplicity of encrypting data on Postgres becomes priceless. First of all, let's see how data is stored on Postgres. So there is some application at the top, and it sends a query or transaction to the database. Then the query goes through PG parser, PG planner, or PG executor, and then it's been executed and written into RAM. So at this stage, the whole change is being written into the shared buffer space at RAM. At the same time, before it has been even acknowledged to the client, the change is also written to the write-ahead log, or WAL for short. Write-ahead log is the sort of a first level of data integrity in Postgres. It guarantees if there is a database outage happening at this time, the logs have been saved even before they have been applied to the actual tables. So when the database restores, the data can be also restored from that state. At that point already, when data is written to WAL, it is already written to the disk. Then for the longer storage, there is a background worker that would scan the so-called dirty pages, the pages that are considered change and not being written to RAM. So it will periodically, depending on the configurations, write those new changes into the heap files that are, let's say, the longer-term storage in Postgres. Essentially, this is the primary storage mechanism to store table data. What else we have here? Okay, so in case there are some columns that take more than a single table, so something really big, those will be separately stored in separate files in tables called toast tables. Of course, all of this happens automatically, almost simultaneously, and in the matter of nanoseconds. But what I want all of us to be on the same page about, it is that before the data entered the database, it is considered to be data in transit. Then everything that you see here in blue, so everything that is written to RAM, is the data in use. Finally, all of the data that is basically written to the disk, so write-ahead logs, actual table logs, heap files, and these big toast tables, this is considered the data at rest. So all of the data that lands on the persistent storage media is considered to be data at rest. And this is essential to understand from the perspective of TDE. Because TDE, which is transparent data encryption, is also from time to time being referred to as the data at rest encryption. So I'd say that the most important thing about TDE is that this is an encryption method that is entirely managed by the database itself. And at the same time, it is transparent to all of the clients that use this particular database. So there are no changes to the application side here at the top are needed. And it's also the database that is responsible for the encryption and decryption process. So encryption from everything that goes to the storage and decryption that comes to from the storage back to the RAM. The interesting thing that the Postgres itself is also responsible for managing the encryption keys. Well, Actually, the management is being produced by the kind of separate key management solutions. That's why I placed them a bit to the side of the database here. But monitoring and managing of the KMS system is still on the Postgres database itself. Okay. So I want to be clear that this is not the conversation about why TDE is the only and the best encryption method. Rather, transparent data encryption complements all of the other methods, including the storage level encryption. And it also has a few benefits comparing to the storage level encryption. For example, it offers flexibility and granularity in the encryption of the database objects. You are the one to choose which table you want to encrypt, how you want to encrypt it, and with what key you want to do this. Also, if the database files are copied or somehow otherwise exposed in their raw form, exposure actually does not happen because what is getting exposed is the encrypted database. And this is particularly useful for physical backups that are being stored in the open Amazon S3 buckets because they're very common exposure vectors. Finally, it adds the additional layer to the whole security of your organization. Even if the storage level encryption exists, having TDE plus the storage level encryption gives you this more strengthened compliance posture that your auditor is asking you about. So TDE is the encryption at the database level. If someone gains access to your data, it still remains unreadable. Think of it as well, a notebook that has been locked not just at the cover, but every single page of the notebook is locked, so no one can understand what is written inside. And the best part of it all, it works automatically. Inside of the database, there are no additional refactoring or change of code required on the application level to make it work. Additionally, TDE offers table-level granularity for precise control, so it is no longer necessary to encrypt the whole cluster if you only want to encrypt just a single table in your database. Just out of interest, how many of you had to push a very simple encryption method to production and then found out that it broke everything? Luckily, not a single person. And this is what we also wanted to achieve when we were building Percona's TDE, simplicity. Simplicity in the implementation. So we saw this gap that the Postgres community, Postgres does not have, do I have 5 minutes? Okay. Community Postgres does not have their own version of transparent data encryption. There were many attempts to introduce one, I think, over the past 10 years, but none of the patches have been pushed to the production. So what we did is we built a fully open source extension. Right now, it works only with the Percona's version of Postgres server. And the reason for this is that for this extension to start working with the vanilla version of Postgres, the upstream needs to accept a patch from us. And we're diligently working on making this happen because this was the ultimate goal of this project, to create a TDE extension that would become a de facto transparent data mechanism for community Postgres. Oh, but even now, if you are a startup with a very small budget, or if you are a big government bank, you can already go and try our TDE extension. It is completely open source. There are no gated features, no paywalls, and also the Percona server for Postgres is one-to-one compatible with the vanilla version of Postgres. The best thing about TDE, in my opinion, even if someone manages to steal your data, they won't be able to actually read it or sell it or expose it to the whole internet because it is still remains unreadable. It is encrypted, so think of it as a very secure vault that, due to a lot of bad luck, got somehow stolen. But the attacker cannot do anything with that vault. They cannot open it simply because they don't have this master key. So the data is stolen, but it can't get exposed. And this is exactly what the regulations asks when they tell you to strengthen your compliance posture, to do something extra to protect your company in case your data gets exposed. So the key is the master. However, if you lose that key, you lose the data. Even if you are the database admin, you still cannot access the data without this one master key. So don't lose the key. In general, the biggest compliance risk that I have heard from our clients was not the lack of encryption. It was the key management. So that's why Percona's PGTD approach includes the centralized key management integrations with the leading KMS solutions. You can integrate Percona TD with Tails, Fortinet, HashiCorp. You can integrate it with OpenBAO if you prefer to stick to the open source solutions. And these integrations provide automatic key rotation, separation of duties, auditability of key usage. And these are not just the good practices to maintain. This is explicitly what is required by PCI DSS, HIPAA, and GDPR. Okay, now to my favorite question. How does your TDE impact my performance? Well, TDE was built with the efficiency in mind, and when our engineers were working on it, we wanted to keep your SLAs the same, as well as your latency and your sanity. And we also wanted to protect the businesses and their data without compromising the speed of their operations and the user experience. So I'm leaving here a link to the benchmarks that were performed earlier in June this year by a Postgres contributor who is not affiliated with Percona. So the blue line here is the performance of the vanilla Postgres. The red line is the performance of Percona server for Postgres with TDE enabled. And you see that the discrepancy in the performance is minimal. Now to the green line, this is the Percona TDE with the write-ahead log encryption enabled. And the reason why this test is separate is that back in June, TDE wall encryption was still in the beta process. And you can see that the difference is actually like down 20% in the performance, which is a lot. The good news is that 3 weeks ago, we shipped wall encryption in TDE to the general availability, and now the difference in the performance is very much the same as between the blue and the red line. So finally, I have to say that open source does not mean unsupported. Percona provides open source tools, however, we monetize off of commercial support and services. So whether you need to prepare for the audit or tweak some performance issues, we are here to help you. But I'm reinforcing here that the support and services are optional. You're free to use Percona software however you want, in how many clusters you want, because we are truly open source, there are no gated features, there are no limits to the usage. So let's wrap it up. TDE encrypts data at rest, and it helps you to meet global compliance requirements. There is centralized key management that ensures auditability and security. Integration of TDE is simple, and the performance overhead is minimal. The whole extension is 100% open source with optional support. All of that means that you can finally meet the enterprise level of compliance without compromising your open source freedom or paying extra resources to do this. If there is one takeaway today, I'd say that security does not have to be expensive or proprietary for any company. It just has to be done right with the open source tools. So there are certainly many things that I did not get to cover today. So that's why I'm leaving the link here where we collected the most frequently asked questions we have received about TDE so far. It also contains the link to the documentation and to the repos. So please go try TDE. It is free, it's open source, and it can really make a difference when it comes to the compliance posture of your organization. Thank you very much for listening to me today. Благодарю.
Okay,
I
yeah,
rushed,
we have
but we
5
have
minutes.
questions.
5 minutes for questions. So, if someone have questions, yeah, okay.
Hi, that's a really interesting solution and an important one for compliance. I want to ask, does it support different schemas being encrypted with different keys? If we have the case where we want to separate different customers' data to be encrypted with different keys?
Well, yeah, it totally depends on the original architecture that you have, but there is no limitation on how many keys you can have. It's not like one master key for everything. I did it for illustration. The KMS solutions are quite advanced. You can have as many keys as you need for actually not just one table, but for a column inside the table.
Someone else had question? Yeah.
Hi. Hey, and thanks for the talk. You mentioned that key management is in the hands of the user, essentially. They can use Vault or whatever other tool out there to manage keys for them. Have you benchmarked the performance or how long it would take to re-encrypt whenever you need to rotate a key? And are there any implications of rotating the key periodically, let's say, I don't know, once per month, once per quarter, whatever is applicable?
That's a very good question. So what we're doing to address this, we are working in partnership with Tails and Fortinix. And because we decided to integrate with them, we're actually obliged to follow their best practices. So this is to answer your question regarding the rotation. I would say that it totally depends on the KMS provider. We are complying with whatever they tell us to do. That's why the integration takes so longer to establish.
Any other questions? Nope. Okay. Thank you.
Thank you.